It's good to be here. Thanks for being here. I will provide some background based on observational records of Arctic climate change and then talk about the connections with the world. I've contributed to the last 3 IPCC reports, but I'm spending more time on the Arctic Council's Arctic Monitoring and Assessment Programs AMAP reports. We have one that just came out. We're working on the next one. They're coming out every couple of years. These have been called like IPCC reports for the Arctic. So check them out at amap.no. In the 1980s, it wasn't yet obvious that the Arctic was warming faster than the globe. Now it's obvious. And what that looks like regionally, you have up to 7 times global warming over the Barents Sea. This is because of sea ice reduction. The Arctic Ocean is about 4 to 5 times global temperature increase. Again, sea ice reduction. So you're removing a cap on the ocean. So especially in winter, there's heat release into the atmosphere. There are an increase in so-called winter warm episodes. Overall, the Arctic, you've heard, is warming 3 times global, and over Greenland, it's about 1.6 times global. So here is a compilation of observational records that we've been compiling through Arctic Monitoring and Assessment Program. So at the top, you see again the Arctic temperature, the global temperature, and a Greenland subsurface 10-meter temperature, that smooth curve, which mimics the Arctic warming as well. Yeah, the Greenland ice sheet, it's losing its cold content, so it requires less heat to be pumped in to reach the melting point. The next curve is the precipitation, so an overall wettening of the Arctic I'll talk more about. The third curve is Arctic rivers. They've increased 12% or so. It's impactful because the Arctic Ocean is only 1% of global ocean volume, but it receives 10% of river discharge. So it's easy to understand the Arctic Ocean is freshening, and that fresh water tends to lie on top, really changing the oceanography of the Arctic Ocean. Tundra greening, longer growing season, more moisture, higher temperatures, and a so-called shrubification. The woody stem plants like willow especially have like doubled in size in the last 50 years across the Arctic. Fire, very episodic, clearly linked with temperatures through lightning ignition. Higher temperatures, more convective clouds, more lightning, more fire. Snow cover decline in May, June, that's leading the sea ice decline that's largest in September. The snow cover decline is a much larger area than the sea ice decline. The changing snow cover seasonally across the northern hemisphere is one of the largest changes to the complexion of the planet. That reflective snow cover is a huge modulator for how much sunlight is then absorbed once the snow cover is gone. And land ice, glaciers. Greenland, the largest single regional source of global sea level rise, more freshening of the North Atlantic. Arctic Canada, also a substantial source, Alaska, Iceland, Scandinavia, etc. This is a very clear response to the observed Arctic warming. The wetter Arctic on the left is the change in rainfall. So overall, a lot more rainfall across the North Atlantic. Snowfall decreasing really because there's an overall increase in precipitation, but more rain at the expense of snow. Because of that threshold, 0 degrees Celsius is being crossed more often. So there's overall globally more humidity in the atmosphere. So over colder areas, there is an increase of snowfall on the Greenland ice sheet. That's 7% more per degree. It's exactly on the Clausius-Clapeyron line, which is water vapor pressure with temperature. So the Greenland cores confirm the basic physics of a warming atmosphere of more precipitation. So as I'm producing these graphics, I tweeting out, and I get decent engagement. 100 retweets, and a lot of concern. People saying wetter Arctic may sound minor, but it has huge consequences. So there is good engagement, and then there's also a lot of denial uh, and misunderstanding. Why is the ice sheet increasing? Uh, that's opposite of the of what we observe. But I would say, a large fraction of the population still is in some form of denial. Their opinion leaders are taking them in a different direction. I'll talk about that potential fundamental solution right at the end of this slide show. Um, yeah, so we reconstruct the glacier mass changes, and if you take, say, every 15-year period of these observationally based reconstructions, you get an increasing rate of ice loss in every 15-year period going forward. So it's accelerating. That's not really surprising. The land ice has a very delayed response to warming because it's a huge thermal inertia in ice masses. They don't feel the temperature changes so rapidly, but because of the inertia. And so a big concern for Greenland irreversibility, uh, which will take a lot of time, but it has started, is thinning into a lower part of the atmosphere. So it's warmer near sea level. If you go high in the mountains, it's colder. Why? There's less infrared radiating downward. There's less atmosphere above you the higher you are in in the atmosphere. So as the ice sheet thins, it has more greenhouse effect, more infrared coming down. So you have dynamic thinning because of flow acceleration of the ice and also increased surface melting. And these combined are an amplifying effect, which we're now putting observations on to measure. But interesting physics of the ice ages, uh, the arrows at the top, the climate's fluctuating back and forth, warm and cold years, lots of fluctuations. These are the temperature variations, and this is the volume of ice here, millions of cubic kilometers. And so we start to tip into a collapse of the ice sheet for temperature anomalies where we are today, about at 1.6 Celsius above pre-industrial. And this collapse happens faster than the growth. The regrowth takes longer. It's a really kind of a sawtooth pattern where you get abrupt collapse, and it takes 80, 100,000 years to regrow an ice sheet. And then you return in this ice age cycle. But it's really, so here we are. Looking at this another way, warming above stable threshold, we're right about here. And as you can see, there's a much larger response of ice loss. This is, time to lose 10% of the ice. Uh, and then it at the higher temperatures, there's less of a feedback because the system is has begun collapse. Um, okay, uh, the Arctic is connected with the Northern Hemisphere system mainly through, or in some ways through this jet stream, aka polar vortex, aka Rossby wave. They're all the same things, and so sometimes you get very wavy patterns, and so a higher amplitude of the wave can be more persistent, getting stuck, and it's moving eastward more slowly. This is observed. And the idea is that this polar vortex depends on the Arctic being colder than the latitudes to the south. But as Arctic is warming faster, this system is becoming more lazy, more slowly moving. So you have a faster flow here when the Arctic is much colder than here. So slowing this down produces that higher wave number. Um, and looking at uh, this spring, uh, this pattern of high pressure uh, had the UK, as you know, drier than normal, quite a bit drier than normal. This is an example of a persistent wave getting stuck in a certain pattern. It can be the opposite. You can have a cold summer, you can have a wet summer. It really depends on where the wave gets stuck. And with limited time, I'm just going to wrap up with ideas about solutions. And so the public tends to focus on this the economy as kind of the single issue. However, uh, it's the economy is dependent on energy. The economy is dependent on environment. Think about farming. You can't really have a farm or a productive land in drought. So these are connected, of course, and this is how we need to think about so systems, perspective, and we can add dimensions, of course, to this that in this balancing act we need to consider fairness. Uh, Education is important, of course. Uh, it's going to take investments to really tackle this. In other words, it's not going to be cheap. Um, but as a return on investment, we get resilience, we get prosperity. And final point, I'm not sure how I am on time. Um, I'm I've become convinced recently that the keys to this challenge uh, involve fixing our money system. When you follow the money, you can understand problems. You don't have to, that's basically that's the key. Understand the money system. Okay, what's up with the money system? We have a money system that central banks issue currency out of nothing. The monetary system is not grounded in physics, and it hasn't been since officially the US left the gold standard in 1971. But that separation from a fixed finite money system began in World War I, even before then, when politicians realized that they, instead of asking the public to pay higher taxes for a war, they could just issue more currency. And so we've been on a fiat money system since then. And if we can return to a fixed, scarce money system, a lot of the solutions will happen spontaneously, automatically. And so I'd be happy to speak about that offline with any of you. Thanks.